for today. I actually met Rana last night, and it's one of the most interesting and insightful startups that I've had, or should we say scale-ups really, I've had the pleasure of meeting recently. And it's a topic that really does blow your mind. It's all about behavioral signals. And so please welcome Rana, CEO of Behavioral Signals, to the stage to talk about his company and the applications of behavioral signals. Thank you.
Thank you. All right, so let's talk a little bit about a very interesting application of deep learning, which is getting inside the thought process, the brain of a human, especially around understanding emotions, behaviors, intent, and essentially the state of mind, which goes a long way in building an AGI, which is like a human. So we largely use AI for automation, for the most part, but we're starting to use AI towards making certain decisions for us. But when we're trying to do that, we're also trying to understand, well, how does a human brain actually make a decision? A human brain uses terabytes of data towards a single insight, and then it uses many insights to eventually arrive at a decision. That's not necessarily linear in terms of computation to sort of how we're sort of building some of the systems today. It's very sort of disjointed. A part of it is sort of not easily understood. And so when we're looking at building these systems, we have to sort of deconstruct that whole sort of thought process. And especially if we are going to now allow AI not to help us make decisions, but actually make those decisions for us, which is just make it, let us know what we need to do, and how do we eventually get there, and it becomes really key. So when you think about a human, I mean, humans don't necessarily just rely on logic. Of course, you need logic to make a decision, but it takes a lot more than just simply logic to get to a human decision point. A human typically would take into account a whole bunch of other things, such as emotions, behaviors, from the face, from words, from tone, among other things. And emotions is also a very complicated aspect because, affect, which is the technical term of emotions, multimodal, it's expressed in different ways. And so then when we're thinking about building these entities, now we have to think about, well, how do we build these algorithms that are similar to the human experience? And I get asked this question a lot, which is like, okay, well, I mean, but should you be doing that? I mean, should you be building a capability that allows it, because it's a very human thing, a machine to actually have emotions and to understand behaviors? Is that first possible? Second, is that right? And one of the quotes, from Marvin Minsky comes to mind. I mean, he was one of the founding fathers of AI, as some of you might already know. And when he was asked, can machines have emotions, or can intelligent machines have emotions? And his answer was, the question is not whether intelligent machines can have any emotions, but whether machines can be intelligent without any emotions. And I think that's a very profound quote, because another way to sort of think about this is that we can rely on two things happening. One is that machines are going to get more and more intelligent, in many ways get to a point where they're going to be an order of magnitude more intelligent than humans. And second, we're going to be relying on these machines quite a bit. So then imagine a future where there is this entity that is super intelligent, many times more intelligent than a human, and we're very, very dependent on it. And would you like that entity to be emotionally aware or not? Because in a human context, a human that is very intelligent but lacks the ability to understand or process emotions is really, the technical definition of that is a psychopath, right? So I don't think we really want to create a future where we have machine psychopaths that we depend on. So then, how do we measure emotions anyways? And one would argue that, Probably it's not as concrete as, say, measuring, say, a blood sugar level in a human. But, we as humans are pretty good at knowing when someone's mad at us. That's, pretty easy to do, no matter how they actually, whatever they say that they feel about us, we kind of know. And so it's this incredible ability that we're all born with, which is to understand the subtle nuances in words, in tone, in body language, in facial expressions. That's something that we just have naturally, and we take all of that account to sort of understand how someone's feeling in the moment. Humans, also sort of use, as I said, emotions and behaviors as an essential element of making a decision. It's an essential part of decision-making process, and we can teach machines to do the same. And to do this, we first have to sort of build these algorithms that have relevant data pertaining to the specific domain that we're trying to apply that engine to, that AI space into. And it first starts with quantifying and measuring various emotions. I mean, you take various speech signals or other modalities, and you use neural nets, which is what we do, to sort of quantify various emotional states. It sometimes takes thousands of utterances to understand a single state of emotion or behavior. And then, of course, behavior is even more complicated because it's context-specific. Why someone's acting in a certain way, so you have to build very, very, very complex custom models towards sort of doing that. But when you do it, you can now build these very enriched experiences that can really change how we live in the future. So here's a implementation of behavioral signals engine into one of the partner machines, which is Temi Robotics. It's actually a social companion that is really sort of geared toward a single purpose of providing companionship and helping people who are living by themselves, especially elderly. I think we're missing the audio.
Morning.
There we go.
John, it's time for your medication. Could you please retrieve your pills from the dispenser? John, please, take your pills.
You know what? Why don't you go somewhere else where you're needed, like maybe the kitchen?
Okay, I will go to the kitchen.
It's good. Bye.
Yeah, so some of us have been working on this problem for quite some time. There are many companies that are focused on various specific modalities of how do you understand emotions or behaviors. A company called Affectiva that we partnered with, they recently got acquired from Media Labs. They've been focused on facial expressions. There are entire departments of universities in the US that are focused on emotional behavioral state, like SAIL, like MIT, Stanford, etc. Our specific focus as a company is to understand emotions and behaviors from nonverbal cues of a conversation, which is essentially how something is being said. Not really the words, not what you're saying, but how you're saying those words, which is pitch and tonal variance, intonations, prosody, among other things. And from that, we can extract a whole wide variety of intelligence, such as emotions like anger, happiness, sadness, behaviors such as engagement, empathy, politeness. And then, the third bucket is an interesting collection of advanced classifiers that are, more sort of industry-specific, like, understanding a customer's experience or level of satisfaction live in the moment. You're trying to understand if someone's stressed or in some sort of distress or duress, identifying someone potentially is in some sort of a control, which is, you're saying something, but do you really mean it, or someone's making you say something, etc. And identifying intent, or intent to do something, or intent to not do something. And so those are sort of, all those things that are now possible to do purely from assessing the emotional and the behavioral state of a participant. One of the implementations is actually looking at a recent interaction, audio interaction, and then creating what you would call a conversational bioprint. This conversational bioprint essentially is an amalgam of a whole wide variety of factors that range from sort of like how fast you speak to various emotional, behavioral states that you exude in a conversation. And then when you put it together, it really uniquely identifies how a person converses. So once you have that information, then you can use that to make decisions around who's the best conversational partner for this particular human who's calling in for this particular agenda. You know, those are the kind of things that you could apply in a call center. And when you do that, you have a significant lift in the KPIs. And that's a quick view of sort of like, you know, what that conversational bioprint looks like. It's really a vector file of 75 to 100 attributes that can be quickly put together from a recent audio interaction, and it doesn't have to be long. It could be, you know, anywhere from a minute to 2 minutes in length. And it's really unique to every person, just like a fingerprint is. How does it help? Like, you know, so one of the implementations, we applied it in a call center for a debt collection scenario in a large EU bank. It happened to be, the name has been withheld, one of the largest banks of that country. And in that situation, when we applied it to the agents that were using this technology, they were able to improve the loan restructuring discussions, which was the primary agenda between agent and client, by 20%. So in stark numbers, it was almost $1.5 million per agent per year. And so with about 150 odd agents that call center had, it was a $300 million upside just by bringing the right people together. Which then, creates that tremendous opportunity of building natural rapport, natural affinity, and then, everything falls from that. So it is really that powerful if you kind of use it in a proper context. So then, let's talk about something else, right? So how's that promise of the fact that, we were promised at some point that the virtual assistants, our Alexa and Google Homes, will become a conversational partner. How's that going? Not very well, right? I mean, I think we all realize that while they're useful to some extent, I don't think we can actually have a conversation with these devices. It's a much higher bar to actually have a conversation. So for example, let's say if Alexa asks you to do something and you respond back with a very sarcastic sure. Alexa has no clue whether you actually mean yes or no by that word that you're saying, choosing to use, which is sure. A human would, for the most part, but Alexa won't. And so there is sort of like, the end of the conversation. I mean, you could ask it to do something, but it not necessarily allows you to actually have a dialogue. To have a dialogue, to have a conversation, you really need to do a lot more than, say, just understanding what someone's saying and speaking in the same language, which is really the, NLU and NLP, which is really solved for the most part. But you need to understand the state of mind. And you need to really understand the state of mind, the emotional, behavioral state of mind, to actually have a meaningful interaction, to actually say something that the other human can relate with. This is what it looks like when you put that.
Have they published results on cancer causality perceptions yet?
I'm afraid not.
Ugh, shoot, what am I going to do now?
Maybe I can find results somewhere else. I will search further. Eureka! The International Human Genome Project has published some preliminary results on the number of study participants and their population diversity. Is that useful?
That is fantastic. Great find, Elsa. Can you upload? It would be great to add some numbers.
Already uploaded in your files.
Yeah, as you can imagine, it's a completely different experience than what you guys have been having with your Alexa, right? And so, but soon enough, I mean, you'd be having conversations like this with your car, definitely the virtual assistants. I mean, these entities that really not only understand what you're saying, your language, your dialect, your accents, but also necessarily how you're saying it and the emotional behavioral state in which you're expressing that, whatever utterance that you're expressing, and then using that into how it's interacting back with you. And then things become really, really interesting. I mean, it's an essential building block of AGI that is an essential human component that you can bring into the AI experience. But I think we could do a lot more than that. And this is where sort of like, now we're sort of into pushing the boundaries. A lot of what I've shown you are the things that we've successfully done, implemented. There are companies using it. I mean, the KPIs are being impacted. And, companies are getting a lot of value out of it. And so they're ready for commercialization. But we're also now looking at other aspects of understanding the cognitive state, which is identifying and understanding intent and also predicting a propensity for a certain action. Well, how do you actually do that? So predicting a propensity for a certain action is something also, known by something, some other word that you're all very familiar with, which is a gut check, right? So sometimes you have an intuition, you have a gut, this is what's going to happen, or it's not going to happen, or you're in a conversation and someone's saying, I'm going to do this, and you're like, no, that's not going to happen. He's not going to do it, or she's not going to do it, or vice versa. How does that really actually work out? What are the factors that sort of drive that human brain, that insight of whether someone's going to do something or not? And that's really a combination of two things, right? The first is, of course, you need to understand what is this conversation about. So it's a domain of the conversation. You have to understand the nature of the interaction. So if you're building an AI model, then you have to build a very specialized custom domain towards a custom model for that particular domain. So that is relevant to that interaction. So it could be a conversation between, say, a doctor-patient, so you need to understand the lingo. Or if it's a conversation between, say, a debt collector and a debt holder, then you also need to understand sort of what that interaction looks like and build a custom domain. So that's something we know very well how to do. I mean, that's where machine learning comes to play. You build a specific set of requirements into a machine learning engine, and then you give it the right amount of data, and it learns from itself, learns on its own. But then the more complicated stuff is, the second piece is understanding the state of mind. And this is where I think, we had a sort of like a dead end for many years, which is, well, how do you really understand the state of mind? And so now using some of these tools, some of these different modalities, but tone of voice is one of them that we use, you can actually get inside sort of the context of the conversation, which is like, how someone's saying something, what is the emotional behavioral state, and then when you put it together, you can actually predict intent. So one of the models that we built, really largely for experimentation purposes for a company, they were looking to see, if we can predict if a client will buy or not buy, or a debt holder will pay or not pay. And so we use some of these early models, and they're still sort of, we're testing the boundaries on that, to make a binary prediction for a debt holder on whether they will pay or not pay. And so we make that prediction in the first 20 seconds of a call. And it's a binary prediction, which is yes will pay or no will not pay. Not percentage probability, but yes or no. And that prediction turned out to be 80 to 83% accurate, which was pretty mind-boggling. And it's actually pretty easy to test, because all you really need to do is take 1,000 calls from the past. You exactly know what the outcome is. Well, don't tell the engine the outcome. Have an engine predict the outcome, match it to exactly what happened. And it was pretty mind-boggling. Needless to say, we were very surprised, and certainly the company was very surprised. And so now we're sort of pushing the boundaries towards doing other more complicated things, such as understanding, the intent to fraud, potentially very useful in banking, et cetera, but also in law enforcement, among other things, assessing someone's trustworthiness and intent to do something or not do something. Why does this all even work? Right? So I think that's an interesting question. So I want to play the next video. Actually, it's mostly an audio, but there's some graphic in there. And it's a test I'd encourage you guys to do on your own, which is, go home and find a piece of your favorite audio clip in a foreign language that you absolutely do not understand even a little bit, right? And presumably, preferably from a movie scene where there are multiple actors, something's happening there. So try to see if you can figure out what's really going on, how many speakers, what is the emotional behavioral state of those speakers, can you understand maybe the subtle differences between someone's excited or happy or angry, and you have no other cue other than the tone, right? So there's no video, there's obviously no spoken words, there's no closed caption, and you're just trying to do it from the tone of voice and see how you do. And here's a quick sort of audio clip where there are 5 clips from 5 audio clips from 5 different movies in 5 different languages, and the engine's processing it, which is like a cheat here right now, so that's why you can do this at your home. And you could also see if you can sort of follow along.
Là, on croise la veuve du tambour de la fanfare. Elle porte la vareuse de son mari depuis qu'il est mort. Attention, hop! Tiens, l'enseigne de la boucherie Chevalier n'a perdu une oreille. Ce rire, c'est celui du mari de la...
Πες μου πως μετάνιωσες, πως θα με παντρευτείς και το πετάω. Στέλλα, φύγε. Γιατί δεν φεύγεις! Γιατί! Θέλω το πελερίδακα. Verga, 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 agáchate, agáchate, agáchate. Ten una pistola, cabrón. Cabrón, ten una pistola, güey. Cargó la verga, cabrón, de una pinche arma.
Ladies and gentlemen, it's indescribable. I can hardly force myself to keep looking at it. It's so awful. The eyes are black and they gleam like a serpent. The mouth is kind of V-shaped with saliva dripping from its rimless lips that seem to quiver and pulsate. And the monster, or whatever it is, can hardly move. It seems weighed down by possibly gravity or something. The thing's...
I think that was the last one. So, I mean, I'm sure most of you did pretty decent. But then again, you really, to do this test properly, you don't want to have this sort of graphic in there and sort of really start to see if you can figure this out. But we now have been able to sort of take this, innate human ability that we're all born with and put it inside an AI engine that can, allow a machine to do this as well. And we can do this real time. I mean, the signals can be processed and extracted real time in the moment. You could do real-time diarization, which is really understanding, how many parties in a conversation, who's speaking when. If multiple parties are speaking, so speaker 1, speaker 2 are now both interacting. You could also identify gender in a conversation of the participant, male or female, and also age bracket. I mean, you could sort of understand, let's say female between 25 and 35, etc. All of this you can do purely from tone analysis. You don't need the facial expressions. I mean, obviously there's no video, and you don't necessarily even need to process a spoken word. And all of this can be done purely, from the tone of voice. And it's really amazing in terms of sort of where the technology has come through. But emotion AI and behavioral AI and actually the sort of these building blocks of sort of assessing the cognitive state of mind is definitely not a solved problem, right? So it's affect understanding is very, very challenging, right? So, if I were to ask or take a quick poll into what do you guys think, gals think, what's happening out here? I'm sure there'd be like a bunch of sort of diverse set of opinions in terms of sort of what is actually going on in here. But when you see the full picture, it might surprise you. And that's why it is a complicated problem, because the full picture is often missing and is often sort of like the area that we lack. But when we have the full picture, things will become even more interesting. So the stuff that we need to continue to build is, one, we have to build custom custom models for specific domains, and there are many, many domains that we yet haven't explored. And the biggest sort of limitation factor there is high quality data, getting access to the right amount of data, making sure it's unbiased, which is extremely problematic, and also making sure that the whole process of annotation and labeling is done up to standards, and then applying it to custom-built machine learning models that are trying to, one, both sort of getting deeper into the emotional behavioral state, but also really trying to solve for an industry KPI that becomes relevant. But there's a lot that is happening, and it's coming together really, really quickly. And I'm really excited to sort of see at some point, some of these components manifest themselves itself into some of the AGI that we are going to see very soon. That's it. Thank you, guys.
Thank you very much, Rana. So we do have a couple of minutes, and I'll join you on stage to see if we have any questions from the audience. Yes, please. Yes, please.
Thank you. It's probably two questions, and I'm sorry it's late now, so I will try to be very structured. But so is it really that your model can understand tonation, or from the tonation go to this state of emotion without any knowledge of like a cultural background? And why I'm asking that is, I know from working in teams, talking to my partner, with a cultural background, my Austrian sarcasm is not understood if I go 20 kilometers away from my hometown, kind of. and same goes for UK, right? And same goes, so sometimes I'm wondering, the tonality then would kind of be, like, what's the tonality of sarcasm? And can you go into this more nuanced emotions as well? Or do you have like these 4 parameters that you have, where you say, okay, these are the rough emotions, let's say?
Right. Yeah, that's a fantastic question, certainly very valid, because obviously there's a lot of differences in terms of how we speak, depending on what language we're speaking, the cultural aspects and the dialects, etc. First off, before I answer that piece, sarcasm is extremely hard to do, right? And that's probably sort of, it's sort of like the last barrier, I'd say, in the emotional behavioral AI, because humans suck at it, right? How many humans get it? And so, understand having maybe an AI do it is a very tall order. So that problem is unsolved. You could build sarcasm models, but they're poorly performing, and poorly, in my opinion, are anything that is an F score of less than 70, 75 is poor. Because if 3/4 of the time you're right and 1/4 of the time you're wrong, you can't really do much with it. And so sarcasm is really, really hard to do. Not something we're able to solve right now. But let's talk about emotions and behaviors, right, and other aspects, right? So now the way this works, there's a deep technical answer to this, but I'm going to keep it simple. Like when you're trying to measure like an emotion signal, like anger or happiness, or let's say anger and excitement, because they're relatively similar but also very distinct signals. What you're trying to do is you're trying to measure a point, where is the signal falling from a point of inflection of a certain baseline that you've established for that data set. And when the signal falls at a particular baseline, a particular point of inflection, that's usually anger. Anger is supposed to always fall there, and if you find the signal falling there, it's anger for the most part. Yeah, so the way that works is, so that is consistent among all languages, all cultures, all dialects, but obviously the baselines shift, right? So like, the tonal languages and their non-tonal languages, and so the baseline keeps shifting, and baseline also gets impacted by cultures, by dialects, by accents, by among other things, right? And so what we've been able to do is we've been able to recalibrate the baseline with a very small amount of data, right? So today, we started off with much bigger data set that we had to use to calibrate it, and now we could do it with 30 minutes of audio. That's it. So if we were to apply these engines to a language set that we've never worked on ever, I mean, we need 30 minutes of relevant audio in that domain, and the engines calibrate. And the magic part of this is that, once the engine's calibrated and the baseline shifted, doesn't matter which part of the world you come from, when you're expressing anger, it's the same point of inflection from the baseline, which is pretty remarkable, right? And that's sort of how it all works. And our human brain also does the same thing. Let's say you're born in a certain country, and then you immigrate to a different country, and you go down there, or forget about that, right? Even if you go from let's say from the South in the U.S., and then you start to live in New York, I mean, your brain's recalibrating, which is how's someone talking? I mean, it's different. It's still English, but the drawl and the accent's very, very different. And your brain takes human brain takes a much longer time to recalibrate. The AI actually can do it with 30 minutes of audio in a few minutes.
Fantastic. Well, thank you, Rana. And that's the end of another final round of applause for you, actually.
Thank you.
What a great way to end the day. Thank you very much. Well, that's a wrap, guys. Thank you very much for your continued attention, and for our lovely speakers for some really thought-provoking discussion topics. We have a closing statement taking place on the Meta stage, and then I think we're open for some drinks. I'd like to send a final thank you to the people that have joined us on